Hello everybody, I'm Dan. Welcome to my Java and Raspberry Pi programming tutorial series. The order in which my tutorials are organized on both my website at pijava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This is basically part 2 of my Android client Land Cruiser remote control, where we'll be integrating the throttle, the forward and reverse motor control functions here, in addition to the steering, which was in part 1. First things first, let's go ahead and crack open a web browser to my website, pijava.com, select Pi Programming. And I am going to scroll down here to the Remote Control Part 2 for Android. Now, basically, this tutorial depends on really that you've completed, like, for example, if you're doing the Android tutorial, you need to have completed this one here and the Android Part 1. And really, honestly, you should be familiar with this one up here, and that'll probably about do it. As long as you've done all these, you'll be good to go. So let's go ahead and pop right in here. Okay, so remote control part 2 for the Android. You can click here for the iPhone. Now I'm just doing this tutorial, so it might take like a day before I've got the iPhone one up here. So if you click on that and you get this page seems to be missing, that's why I don't quite have this done yet, but I'll have that in there very shortly for the iPhone. So in this tutorial, I'm going to continue to expand on the Android remote control app. In my last tutorial, JNI, C++, and PI GPIO speed control, I demonstrated how to control an ESC, which is an electronic speed controller, to drive the motor. Now, I will be using the native method from that class in the Android app, so you'll definitely want to go ahead and make sure you've done that. So let's go ahead and get started here. And what I'm going to do is, first I'm just going to go ahead and bring up my webcam here, and I've got the car sitting here waiting to go here. And I'm going to talk a little bit about the wiring that we've got going on here. So obviously this is the battery, and I'm going to go ahead and just plug that in here. All right, and I'll move this just a little bit closer here as well. Let me refocus. Okay, so basically I've just mounted the electronic speed control up here. You got the big thick wires coming out here down to the motor, right? And that's pretty straightforward on all that. Now this little wire here, let's see if I can twist this a little bit, get a better angle on that. So this wire coming out of the electronic speed controller, right, has a white, a red, and a black, right? And I talked a little bit about that, and if we follow that wire up here, I'm going to turn around the card to this angle here. Let's refocus. So coming out of electronic speed control, I've just got this wrapped around here, and then just a little wire tie up here, and then popping into the breadboard here. And I'll show you a little bit more about the breadboard here in a second here. So I'm going to turn this back around here, and coming out of the servo right here, this wire right here is the three wires coming out of the servo there. The dark wire, the red wire, and then the communications, which is the lightest wire. And I'm just running that right underneath the battery up to basically right over here. And I'm crisscrossing into the breadboard there. Okay. Now on the breadboard itself, now what I'm going to do is, maybe I should just turn this, get a better angle on this here. Yeah, that's a pretty good angle there, I think. Let's see if I can get in just a little bit closer on this. I'll refocus. All right, I'm going to go ahead and remove this wire, these 3 little wires that I've got going on here, so you can they'll show you what I've got going on the breadboard here. Okay. So coming out of the electronic speed controller, the red wire right here, that wire is carrying a positive 6-volt value there, right? And the main ground is this black wire right here that's coming out of the electronic speed controller, okay? And that is popping down on my breadboard, I have the black one going into pin 15, okay? And this is a little hard to see, but this blue wire right here that's connecting that is connecting from pin 15, which is the negative coming in here, all the way over to pin 9, which is where I have my negative coming out of or going back into my servo here. Okay. Now the red wire that's coming in here is connected into basically this row 16 here, and I've got that coming all the way over into row 8, which is the center, the red wire coming in here to the servo. Okay. So this is essentially powering the servo at this point, and that's really all I'm using. The black and the red wires coming out of here at this point is for powering the servo there. Okay, so now we need to add in some communication wires here. So what I'm going to do is I've got these 3 little wires here. I've got black, white, and then kind of this light tan here or there. And so I'm going to take the white wire and I'm going to put that into row 17, which matches up with our communications line here, because we're going to be sending communications back into the electronic speed controller through that white wire. Next, I'm going to hook in the black wire onto row 15, okay, so that it shares the black wire coming off the electronic speed controller, shares that common ground. Okay, and then the last thing I'm going to do is I'm going to put this last one into row 7, so that this wire, which is our communications wire that'll be coming off the Raspberry Pi, will be communicating over the communications wire, this light wire here, to the servo. All right, let's go ahead and pull this back out just a little bit here and refocus. Now I want to take my Raspberry Pi, and I've already got my Raspberry Pi hooked into, I'm going to unplug this here real quick just because I want to kind of position my Raspberry Pi in my getup here so that it underneath this wire here. Okay. So I've just got the Raspberry Pi being powered via the AC outlet right at the moment there. I don't have it being powered by my battery bank right at the moment here. So I'll do that in the next tutorial when I actually put the body on, and we'll have the Raspberry Pi sitting up in the RC Land Cruiser's top there. Okay. So coming back here to the website real quick, I'm just going to go ahead and minimize this. I'm going to be hooking the ground wire into this pin right here. I'm going to be hooking the white wire, which is the control wire for the ESC, the electronic speed controller, into GPIO 18. And I'm going to be putting the control wire for the servo, which is kind of that light tan wire, into GPIO 23. Okay? So we're going to skip 2 pins, hook up the ground, skip 2 pins, hook up the white wire, skip 1 pin, and then hook up the tan wire. Okay? So let's go ahead and pop back. Over here. And 1, 2. Okay, so I'm going to go ahead and bring this in, so hopefully you guys can kind of see that. Let me refocus. Alright, so basically that's all in the back row here. And I got 2 open pins, then the ground, 2 more open pins, then the white, and then 1 open pin, and then our kind of tan wire there. Okay, so now we're all hooked up and kind of ready to go on that. I've just got this little cotter pin right here. I'm going to release the tension on that so I can just kind of set that there. And then all the wires are out of the way of all of the wheels and everything, and we are set to go on that end of it. All right, let's go ahead and pop back over to, what I think I'm going to do is, I've got this light on up top there. That's a little better. Not quite as many shadows. It's a little darker though. Okay, that's all fine. Excuse me. Okay, well, first thing we're going to do is we're going to set up the RC server class. And I've added a few more things into that here. I basically added some of these, for lack of a better term in Java, these, well, basically these static file ints here, the private static file ints, which are 111, well, you've watched my tutorial if you've gotten this far here, but basically I changed this variable name, which used to be GPIO pin to steering GPIO pin 23 and ESC GPIO pin 18, right? And the hertz is 74. Okay, I added this instance variable ESC of type ESC type, right, which was from the ESC class that we created in the previous tutorial there. And then on the constructor, I'm going ahead and I'm initializing that new ESC object, okay? And here's where the constructor is invoked. Once again, I'm listening on port 4141. And instead of the PW angle equals, I've now added a couple of if statements in here. So if they contain steering equals, or if this contains throttle equals, it will invoke two different methods here, steering or throttle, okay? Coming down here to steering, pretty much just the same as that, before it invokes the native method turn wheels, and instead of passing GPIO pin, I got steering GPIO pin, which of course is pin 23. ESC GPIO pin is 18, which happens to be the hardware pulse modulation pin. Okay. Now coming down here to the throttle method, which I've added in brand new here, it's pretty much the same as that, only we needed a little bit of a delay. So I'm invoking the gas pedal method from the ESC class from the previous tutorial, passing in the pin 18, the hertz 74, and then whatever value. Now we're sleeping, we're putting the thread to sleep for 20 milliseconds there, and we really need that because that native method there needs about that much time to actually set the pin, the hertz value, and then of course the range that we're setting in there. Okay, so that's what's going on there, and of course I added in this uninterrupted catch exception. So let's go ahead and pop over to the Raspberry Pi and get the server class started here. So I'm going to open up my web browser, not my web browser, my terminal, and go to cd Java, cd Land Cruiser, right? And leafpad rcserver.java. Okay, so here is what we had left over from before. I've already got the Java or the PyJava website up here. And let's come down here to the RC server class source code, and we're just going to highlight all of this. And we're going to copy and come over here. I'm just going to hit Control A for everything, just delete it and paste it right in there. Okay. All right, so now that we're done with that, let's go ahead and come up here and save this. We'll just go ahead and close out of that, minimize that, and we'll do our Java C rcserver.java. Okay, no errors, and let's do sudo java -d java.library path equals dot, which is the current directory, and then RC server. Okay. Now we're listening on port 4141. So now we're ready to head back over to Android and put that code in there. So let's go ahead and just put this into a smaller window for later. And we'll go ahead and minimize that. Okay, let's go ahead and bring up our Android source code. So here's the everything from the last tutorial, part 1 there for the Android stuff. Now we're going to come over here to the RC client class. And I'm going to talk a little bit about what I've changed here. So basically, applications in this particular state are usually kind of in the prototype stage. I haven't gone over any of what's called Java patterns, right? Patterns are really awesome, and we'll cover all that there. And so, but basically, I'm just talking a little bit about how a program evolves and some of the changes I've made because we're evolving it out, right? And so I've added in all of the ESC neutral forward max, right? These particular values, the GPIO pin 18 and the hertz, and changed all this to kind of match what we're expecting in the, oh, hello, never mind. Come on back down here. Sorry, okay. So, we want to go RC server class here. All right, so RC client, sorry. So scratch, never mind what I was saying there. I am connected through on the Raspberry Pi. I've set up my Android as a hotspot. Remember that from my previous tutorial. So I'm connected into PyJava here, and if we open up a terminal, another terminal window here and type in ifconfig, right? We get the IP address of 192.168.43.131. So the lease it had on that DHCP IP address is still holding there. So that's all the same there, okay? And everything else is pretty much good here. Only I've changed the method call from turn to steering, right? And I did the throttle, added that in here, and so basically we're passing steering and throttle instead there, okay? Other than that, it's pretty much about it, but nonetheless, we'll just come up here and grab all the source code for that. We'll copy that and minimize this. Let's come over here, RC class, and we'll paste all this in. Okay, so we've got all that going on there, and now when we come over here to the main activity, what we want to do there, and you can see we already have a little error here because the turn method no longer exists from what we were doing before. So we're going to come back here to the web browser and go ahead and grab all of the source code for the main activity here. Well, actually, I'll talk a little bit about the main activity and what I'm going to do while I have the big font up here from the website. So I've added in a few more reference variables for some of the GUI elements that we're going to have there. I created this Boolean stop equals false, and I've got steering PW equals 1400, which is basically puts the steering right in the middle, and throttle PW, which is pulse width, for 111,000, which puts it right in the middle. Okay. Now in the thread class there, I'm no longer using like 1100 as like this, flag there. I've now made the program kind of evolve into a better way there. So if stop is equal to true, while it's in its while loop, it'll go ahead and break out, okay? Otherwise, I've added in, instead of old PW, right, old steering PW and old throttle PW, because we don't want to keep sending, obviously sending information over the socket connection, if it's the same stuff there, okay? So if those values aren't the same, so we're pulling in basically steering PW, which is this instance variable right up here. Whenever that changes, it'll go ahead and invoke the steering method over in the RC client class there. Okay, and then of course it'll set the values the same so it doesn't keep repeating it. Same sort of logic flow with the throttle, invoking the throttle method there. Okay, all right. Now on the button start here, right, I've set stop equal to false, steering PW equal to 1400, throttle position equal to 111,000, which basically says we're going to center the wheels and we are going to put this into full braking mode, which is essentially like, think of it as like neutral, right? It's just the middle. It's not forward, it's not reverse, it's right in the middle. It actually sets the brakes because of the electronic speed controller that I've got, okay? And then we're going to start the thread and set the button start enabled to false. Okay, now on the stop here, what I'm going to do is, of course, set the button stop enabled there, and then set the pulse width equal to 1400 on the steering and 111,000 on the throttle. And I'm going to give it 1 second, 1,000 milliseconds to sleep, so that it has time, the thread has time to go ahead and reset those here before I go ahead and change stop equal to true, which will then cause the thread in this while loop to go ahead and break out of here and invoke the close up method there, okay? So that'll kind of stop the, if it's at full throttle or something like that and you hit the stop button, that'll put it back to braking mode and centering there. All right, so that's pretty much, oh, sorry, that's the stop. This is the stop here. So that's pretty much about it for the buttons there. I've added a new seek bar throttle, so this is still going to be a really cheesy layout. We're still in the prototyping mode, and and it's by no means a final product. And I'm going to add and show you some cool stuff along the way when we do get it to that final stage there. So this particular one, much like this other one there, starts out at 1130. This one starts out at 81,000, and 81,000 is our let's go back up here. 81,000 is our full forward there, right? And our full reverse is 141,000. And so the difference between the two is 60,000. Now, we could set our range so that whenever we do the slider or whatnot on that, we could actually move that, 1 out of 60,000. I'll kind of explain this later. As a matter of fact, you know what? Let's go ahead and I'll explain that in the Android source code when I add that to the XML there. Copy, and let's go ahead and paste this all in here. Okay. All right, so we've got a few, just a couple red things there that we need to add to our activity main XML file up here, basically our GUI. All right, so let's come down here, and what I'm going to do is I'm going to take this stop button and I'm just going to drag this down here, right? And then I'm going to take the start button and drag it down there, and that'll free up just a little bit of room here. I'm going to add a new text view right underneath here. And let's just go ahead and call this, what did I call that text view up there? Text view progress. Okay. And I'm just going to call this text here throttle when this catches up with me here. And sometimes I find it easier to switch over to this little text tab for some of these things. I want to set the color equal to white. So this one here for the throttle, I'm just going to come down here. I can pick any line and do Android text color equals, and we want this to be white, which will be pound FFFF 6Fs. 6Fs looks good. All right, so back to our design mode there. All right, let's go ahead and throw in this second throttle here, right? And or seek bar. I'm sorry. This will be the seek bar for the throttle. There we go. Okay, let's drag this edge over here and this edge over there. All right, and I think I called this seek bar throttle. We'll just try that, and if it works, it works. All right, so we could set the max at say 60,000 and the progress halfway through at 30,000, right? And then we could have our base value at 81,000 plus 60,000. And every time we moved our finger across from one end to the other, it would trigger it, and we could possibly send 60,000 commands over our socket connection just to control the throttle and from basically neutral or full brake all the way to forward, or neutral, full brake all the way to full reverse, right? Which is just ridiculous because the motor doesn't have that sort of precision. So what I'm going to do is I only want a total of 60 steps, okay? And so right in the middle of that, we'll do 30 steps, okay? And so that basically gives us 30 steps of forward and 30 steps of reverse for a grand total of 60 steps. So we'll be setting our ratio back up here in the main activity. Oh, text view throttle. What did I call that thing? Text view progress. No, I know. I set the name wrong here on this one here. This needs to be text view throttle. All right, there we go. Yes. Okay, so coming back over here to that slider here. So our seek bar there, so what I'm going to do is I'm going to take I, which will be a value from 0 to 60, and I'm just going to multiply that by 1,000. So this calculation in here will be 0 to 60,000, which added into our minimum and maximum values for the speed controller, which is 81,000 and 141, right? So 81 plus 30,000 is 111,000, which is just basically our neutral or our brake there. Okay, so that's how that all works there. All right, let's go ahead and run this and start playing with it. So I've got my Android phone plugged into the USB port there, and I'm just going to go ahead and click on this. Should have Jeopardy music playing while this goes there. All right, my Samsung is my Galaxy S7, so I'm going to go ahead and click OK on that. My build is going down here. And while that's going, I'm going to go ahead and just switch over to the this here. Okay, Maybe I'll turn that light back on because that was a little bit lighter. That was kind of nice. I want to turn on my speed control. So I got my beep and my second beep, so that's all good there. It's detecting something. And let's pop over to the, all right, to here. My Android has launched the app. We're good to go there. And let's go over to, don't want to distort that too much. To the Raspberry Pi, and right in there. I think that'll be good. Maybe I'll make this just a little bit larger, so we'll be able to see those commands kind of roll across there a little bit there. All right, and I'm gonna have my unplug this. All right, here we go. So I got the app going there. Let's go ahead and refocus in here. That all looks good there. I'm going to just tap on the start button right down here. Okay. And then I'm going to test the steering here. Right. And so we've got our steering going well. Got our numbers going across there. Move that really fast. All good there. Okay, now what I'm going to do is just going to straighten that out there. And now let's test the throttle. Okay, so we can control our throttle pretty precisely. So you can see I barely have the wheels spinning there. And then I'm going to go ahead and turn this from side to side. So far so good. Everything is working just as we expected. I'll just leave this fully turned like that, and maybe I'll straighten them out. Okay, and now we're going to test our reverse here. Right, and move some of the number. There we go. Now you can actually see the numbers. So hopefully I can keep that in there. All right, go ahead and we'll test the full throttle forward and full throttle backward. Yep, and you can see how it hits those brakes. So that's working pretty good there. Full reverse. I do get a little interference jump there when I come it back down sometimes there. I think I might need to increase that 20 millisecond delay. Okay, so I'm just going to go ahead and just start the wheels spinning a little bit. Go forward here and then just test the side to side. So all in all, it's fairly responsive. Everything's going pretty good on that. We can hit that. Now let's go ahead and do this here. Let's go ahead and turn the wheels all the way that direction, and let's hit the stop. Okay? You can see that did exactly what we were expecting it to do. It stopped the car. It turned the wheels straight here. And as you can see over here, it closed the socket connection there. So everything worked out pretty good on that. I think that'll pretty much do it for this tutorial there. I'm going to go ahead and I don't really have any final thoughts that I'm going to leave you with here. I'll be doing the iOS tutorial next, pretty much the same format as this, only with the iOS code. And then after that, I'm going to put the body on, dress this thing up, and we'll drive it around a little bit and play with it. So, and I'll do a little bit of error trapping and error handling, so we get some responses from any failures that might occur in the Java native stuff there. So I'm going to go ahead and minimize this, minimize that, and that concludes this tutorial. Thanks for watching.